Okay, so I had a lot of people that were confused with the third and the fourth one. Dan, can I have you help me with this one? I'll have you walk me through it, okay?
Yeah.
All right.
I'll walk you through.
So 3. Is this statement true? 3 is the same as 3 plus 0?
Yeah.
Yeah, okay. Do the rest of you guys agree with that? Okay. And is that the same as 3 plus 0 times any number, we'll say x?
Yeah.
Okay. So what if our x was I? So
Yeah, 3 plus 0 I.
3 plus 3 plus 0 I. So that is the same as that, right?
Mm-hmm.
All right, now can you come here and help me with this?
Yeah.
So we're imagining that the imaginary number is there?
So you are imagining that the imaginary number is not there.
Good joke.
Very good.
So all of these numbers from our warm-up are actually imaginary or complex numbers?
All those are actually complex numbers. That's very good, Bridget. All right, last one here. I can just do this one. If we would write this as 0 minus 6i. John, what would my real part be?
I just picked negative 6 is real part.
Negative 6 is real part, so just that right there, you think?
Yeah, but I changed my mind. I think 0 is the real part, but I think we also can do 0 times I there. Then we cannot find the real part.
Okay, so you think, if I'm hearing you correctly, that I could say that negative 6i is the same as 0i minus 6i?
Yeah,
So there is no real part?
the same. Yeah, the same way. Yes.
Okay,
But then
we could do that.
But then
Kelly, you
can't
can
you
say
do
something?
algebra and it would be like 0 minus 6 because you only look at the coefficients?
0 minus 6.
Like when you subtract the coefficients? Like you would, if it was 2x minus 4x, you'd do negative 2x.
2x.
So
So
isn't
yeah,
it the same thing?
so that's, yeah, that's right. But can't we always add, like we showed over here, if we have a number, we can always add 0 and it's just still the same number?
So I'm a little confused because I think we can say the real part does not exist instead of 0 because we cannot find the real part in this way.
Okay, and why can't we find the real part?
Because we can add 0, but we also can add 0 times I. Why in this case we add 0 times I, and this in this case why we just add 0 instead of 0 times I?
You could add 0 times I. It's,
Because isn't 0 times I the same as 0?
Yeah, but the same, but why this in this problem we add 0 times I, in this problem we add just 0. Why difference?
well, in this problem over here, we could have added 0 again, right?
Yes.
And isn't our statement still true?
Yes, so I think we cannot find the real part here and we cannot find
The imaginary part
there.
in the... Okay, I see where you're coming from. I guess we can talk a little bit more. I'm gonna get the guys going on the next thing and then we can keep going through that. Does that work?
Okay.
Alright. Alright, so going through this one here. Our last one, our real part here was 0, and our imaginary was this minus 6i. Right? Okay. Alright, so the next thing I want you guys to please write down in your notebook is our second standard that we're going to be working on today. It says that an imaginary number has the form a plus bi, where a and b are real numbers. That's right. Okay. So moving on. So now we have this imaginary number I. We've defined it as the square root of -1. Now let's do some operation. Let's multiply it. So I squared then is the square root of -1 times the square root of -1, which is -1. Alright, so now can we look at that last do now problem number 5? Before we couldn't solve it. Now that we have this I, what do you guys think? Can we solve it? What do you think, Dan?
Yeah.
What would it be? What would X be?
It would be,
X will be I, right? Because
yes.
X squared,
I.
very good. Because X squared is the same as I squared. Now we have here that I squared is -1. Very good. Alright, so with your partners, I want you guys to try to multiply out and see what I cubed and I to the 4th are.
Which is negative I. Which is negative I.
So I'm doing these little stuff, you know? So that way
Yes, I have
negative I
I.
times,
Negative
oh
I.
my gosh,
Or no, sorry, negative I
times
times
the
I.
square root of 1.
Which is negative square root of 1 times the square root of -1.
What?
Negative square root. This is what I'm
Negative
trying to say.
I. There we go.
Negative square root of -1 times the square root of
So Kelly, why
equals negative squared.
Well, this
equals
is I.
negative
Okay.
Hmm.
Did you see that, Kel? I don't see.
Yeah. I was thinking just
Yeah,
plug that in.
exactly.
Why isn't it negative I?
Where?
Why is it I that's fortunate?
Because, yeah, negative. Alright,
You have to do it again.
do it again.
So, negative square root, so that's negative I here, right?
Yep. So
Times I,
times I.
so y, oh, negative I squared.
You can think of it also I squared times I squared equals -1 times -1.
You guys are always so neat and so pretty in my phone.
Alright, looks like everyone's about ready to move forward. So could I have Alex come up here and help me with IQ, please?
Yeah.
How did you and Kelly solve this?
Okay, so I just rewrote it again. Okay, so then we said that one of these equals -1, or two of these, I mean.
Yeah.
And then multiply that by -1. And then Kelly reminded me that this equals I, so then it's -1 times I. So, I think that's the right answer.
Very good. Same, Bridget? You come up with the same?
Uh-huh.
Alright. Bridget, can you come help me with I to the 4th power, please?
Well, I tried to do a shortcut here, because if we already know that I cubed is equal to -I,
Uh-huh.
and then this is where I got stuck.
Okay.
So that's where we basically end up with -I times Dan,
What?
Times I.
Yeah, it's times I.
Mhm.
right?
Yep.
Okay. And then you end up with -I squared. And then you get negative. And we know that I squared is equal to -1, so you get -1, which is equal to 1.
Very good. Kelly and Alex, did you guys come up with the same? Dan, I noticed you did something else. Or you said to Bridget that we know I to the 4th power is the same as, you say
I squared times I squared.
Alright, anyone else do it like this?
Kind of.
Kind of? So no. I squared is -1 times -1, get positive 1. So as you guys can see when you're doing this, there is no one correct way, one correct method. So Bridget might do it this way, Dan might do it this way, they are both correct and they're both very good ways to do it. Okay? Alright, so we're gonna do a jigsaw activity. I'm going to number you guys off. 1, 2, 3, 2, 3. Group 1, I want you to try to simplify it I to the 9th power. Group 2, I to the 16th, and group 3, I to the 21st. When we're all done, I'll split you guys back up and we'll have you guys teach your peers how you did these problems. Okay?
So where's group 3?
Make sure you put over.
Well, I guess I could have left your chair.
That's okay.
Except for I'm just rolling around the room.
I know,
I
it's
think
it's
you're
hard to, I know, it's hard to grasp.
Oh,
I'm over here, sorry. Okay.
Yes.
I to the 21st.
remember there are many different ways you guys can do these problems.
So how would you do it first?
So if you get done and other groups are still working, I want you to please try to solve it using different methods.
I don't understand why we need to have Okay,
So we
so-
know this.
yes, we do.
So
Oh, I squared to
We know I squared is -1. And to the 8th. No, you guessed, what'd you say?
I just my strategy is
-1 times -1 times -1.
Oh, you wanna keep going?
So you
All the
say
way up to
pattern?
21.
yeah.
Well,
So we know that I to the 4th
yeah,
You keep
no,
doing
is,
I'm not gonna
One.
do that.
so
If
can't
I
we just
listen
do
to you
I
too
to the
long.
4th?
Yeah.
But if we say like I to the 5th,
Let's just keep
is the
writing
same
everything
as the I to the
because
fourth
then
times
maybe
I,
still put one
Yeah.
that
right?
we're done.
So that's gonna be I again.
Yeah.
No, so we still just better.
Oh.
Yeah.
So if it repeats, then can we figure out what this
Oh.
would be?
So, 9, 10. Oh.
So,
Then we can get 20 here.
yeah, so if 20, if we know that
It's
it's
a one or
gonna be
negative
one
one?
again,
Yeah.
then we have to,
Do we know if it's one or
so then to the 21st would be I,
Oh,
right?
yeah.
That's true. Or we could do like.
You're so smart.
Straight to 1 to the 16. Which also.
Good.
How do you know that?
My parents.
That's the same as negative 1 to the 1/2.
To the
16.
So that's another way to do it.
And then what do? You add, so you have 16 plus 1/2 to the negative half. Negative 1 to the
You multiply them. So it's -1 to 8.
Just what you said.
So there's another way to do it. Because Alex didn't like in that way first, because they have like a value for I. So
Did you guys get yours solved?
more apt to like the one
How many ways did you do?
square root.
That's true.
One, but we looked together.
Okay. Try to solve it using
I
that.
don't think they want to do that
Okay.
idea.
They're
Most of
gonna
them
get
don't
stuck.
like fractions
They're
and
gonna get stuck right
exponents.
here and be like, what do I do? Before they did this. Or maybe, I don't know. Maybe if they did rational numbers for this, maybe they would, maybe they just do it.
Be good to do it right after you've done exponents.
So you could do, you just had that, right?
It's like rational stuff.
So you
So
have
rational numbers, I mean, most of
I
them have to do
Yes.
like, rules and fractions.
times
There's some more textbooks.
Hmm?
Very smart.
Really like the kind of range.
That, we all are very smart in our own ways.
We didn't even teach that whole section.
Because I felt like, just the variation in the levels of inputs are really a little hard for like the realization in class.
Yeah.
But like, if that's what textbooks are.
Yeah, I thought the textbook was either, like there was stuff that I didn't use.
Yeah.
Well, maybe it's supposed to be like a Tuesday lesson,
Something different.
but yeah.
It was good, I didn't find out what just.
Like how you did last time.
I should
First did it one way, you should do it another way. Trying to way you can solve it.
Smart.
That's fine.
probably.
It's like, it's not worth the same thing.
Did you guys find that method?
Tools on it, you know.
Yeah.
It's
It's
similar.
that one.
Well, you see.
Do you think, do teachers when they teach, do they
What was yours?
like have
So,
PowerPoints
we
or stuff
know
or
that,
every day?
we know what for,
They do?
fourth is.
Teach them about
And then
that.
I know that it has to be broken down into like, when I was in high school, one, this is my 4 and 5
Yeah.
in high school, so like, that's a lot of things matters, and I had another day, like, use each other's resources. and
so then when you
just
add your exponents,
So long.
that's awesome,
We get I first.
and so this is 1, 1, 1, 1, 1, so multiply all those together and add that.